heard was just an earthquake.
The quake did damage some brick buildings like this one in Baltimore and spires at the Washington National Cathedral. Our very own Chief Chuck is now joining us, and he's here to walk us through the science behind this earthquake. And Chuck, I think a lot of us here on the West Coast are wondering why this thing is making such a big deal out there.
And why it was felt for such a large distance. Take a look at this graphic we put together in the weather computer for you. It was felt up to about 400 miles away from the epicenter. This is up in northern portions of Ohio, and also just outside of the Atlanta metro area, another 400-mile distance from the epicenter of this earthquake. So why was it like that? Dan, we've got this for you. We're talking West Coast right here and East Coast right here. Now on the West Coast, our plates are really kind of broken up a lot. It's almost like having loose gravel in there. However, on the East Coast, it's bedrock. I mean, we're talking solid rock underneath the surface. So here's the difference. I'm going to hit this, and you're going to see if you can feel it.
Not very much.
Not very much. But how about we do it at the same distance away from the hammer, and we hit the bedrock.
A lot more.
Yeah, the energy is really transferred farther when you have the bedrock than it is on the West Coast, where you have lots of faults going on. And, you know, on the West Coast, we can also tell, you know, we would be talking about which fault this earthquake happened on. On the East Coast, you can't do that, really, because there aren't that many faults. It's just something's going on, and seismologists aren't exactly sure what fault line that's happening on because it's such solid bedrock.
Huge difference.
Yeah, huge difference. West Coast, they aren't felt very far away from the center. East Coast, they're felt for hundreds of miles away.
All right. Thanks for the science lesson.
You bet.
Great explainer. Thanks, Chuck. New attention.